We're at the BOSEF event outside Bowling Green at a very interesting installation.
We are members of American Municipal Power. We are a not-for-profit.
You hear the head giving us a
We
talk.
own all our electric lines. We have our own city in Ohio will be 40% renewable. We just bought 36 megawatts of hydroelectric on the Ohio River. There's 5 new hydroelectric plants being built through American Municipal Power, and we bought 36 megawatts of the 350 megawatts that they're building there. We also invest in landfill gas to energy. We buy that from all over Ohio, and we also get some hydroelectric from New York State. We have also invested in a brand new clean coal facility in St. Louis, southeast of St. Louis. We're buying 41 megawatts of clean coal and 50 years of coal through the Peabody Coal Company. The new clean coal and the coal mine are right next to each other, so it will be our cheapest power. We're trying to stabilize our power costs going forward. We believe that power costs will continue to rise, and we don't want to take part in that. CO2 sequestering, NOx and sulfur and all that, that'll be removed, but the CO2 sequestering, at least yet, unless it's required. We were investing in the American Municipal Power, and they were building another coal plant on the Ohio River, and due to costs, they suspended that project. They had bought the property and everything, and had contracted for the boilers and all that with the Japanese
CO2 sequestration.
They killed that. 4 turbines, it was $10 million. It's financed over 15 years. And we own 4.1 megawatts of the 7.2 megawatt rating. And we get about 25% of that over the course of an average of a year. And so it's enough power for about, last year, 1,680 homes. It varies, 1,800 to 1,680, somewhere in there every year. And really, it's been above expectations. We estimated about 13 million kilowatt hours per year, and it's actually been more than that every year.
Do you know how much what the breakdown is in energy use in a family home between heating and lights and so on and so forth?
Not the breakdown, but it's about 700 kilowatt hours per home, you figure, and so that's what we generally estimate.
But that's the electric use.
The electric use for the whole home. So we haven't got to that extent yet. We are Bowling Green is really kind of way out there. I mean, I got to admit that my boss, Kevin Maynard, he's the new director of utilities. He's having us put in a smart grid system. I don't know if you're familiar with that, but we can read all the electric meters and all the water meters through the electric lines every 5 minutes. So we can get time of use. We'll have the ability to shut people on and off from the business office. When you have 7,200 reads or 7,400 reads in a week or two when the students leave, the meter readers were suicidal, and now we can do it with just a touch of a button on the computer. That system is about 80% complete right now, and there's a lot of things that you can add to it to make smart grid connections to the home, and where people can find out what's using all my energy and all that. But right now we're not that far yet. We're just going to be reading the meters and shutting people on and off through the electric lines. Was in the whole world, and they said no. I said about 5 blocks from here. But it generated 12 kilowatts, and it lasted about 20 years. And Henry Ford wanted to preserve it at his museum up here, and he had approached Cleveland back in 1829 to bring it to Detroit, and the city council said no way, that's one of our treasures of Cleveland, and then it got tore down for a road. Diameter,
33,
and
33 feet.
there's another pipe inside there, and then the annular space is where they put these large bolts. And they go down 33 feet, and that annular space is filled with concrete. Okay, and then it was concrete on the outside to hold it down. And that's what holds it in, 14 feet diameter, 257 feet high. Each blade 132 feet, weighs 14 tons each blade. The nacelle where the turbine is located weighs 77 tons. And so you got over 130 some tons up on top.
They're made of aluminum or steel or?
Fiberglass epoxy.
Fiberglass epoxy.
And they're getting better. They're making them lighter and they're becoming more efficient. They work at slower wind speeds now. That's why we're getting that 35% out of the General Electric.
Fiberglass is basically a polyester, glass filled polyester. At least that's what typical fiberglass is. So it's still lightweight.
This is not light. Each blade weighs 14 tons. Pretty good. It's connected right into these lines right here. These are our transmission lines, and we installed them specifically for the turbines. There's 2 turbines hanging down there. There's 2 turbines hanging right there. And this takes it to one of our substations. It's on Poe Road there, down by the fairgrounds. I don't know if you're familiar with the fairgrounds is. And we have a substation there. And since the power is coming in like this, Amp Ohio, since we're buying from all these sources, you know, we have multiple sources of power, they're doing our load management. So the loads to the homes, you know, is evened out. So
now we're going to go into the control, but not.
It goes into this transformer. This is where we convert it to 1270 volts. It goes underground out to our distribution system, to our substation. So this is what boosts it up right here.
So everything is pretty self-contained.
Yeah, pretty cool.
How's the frequency control?
It's set at the same as our distribution system, so there's no interconnection problem. It's whatever cycles that is, I forget that, I should know that, but same as our distribution system, so there's no problem connecting them.
But now the frequency coming from the generator is going to depend on the rotation.
Right, but it gets converted here.
That's what the transmission does.
Yeah, but
We're turning at 16.5 revolutions per minute, always. It never changes. So the only thing that changes is the transmission and the wind speed, okay? So the generator is varying, but it's at 826 RPM right now. So you're going from 16.5 revolutions per minute, but we're spinning the generator at 1826 revolutions per minute.
And what we're hearing is that transmission is boosting the
Yeah, the generator, one or the other, probably the generator. Right? You know, we're at about, it jumps around. You can see how the pitch is jumping around. It never stays the same. Wind is at about 9 meters per second. And then we're generating 800 to 900 kilowatts.
So this is a good day.
Yeah.
We were talking about research projects.
Now we're back at the Bowling Green campus.
Whatever, some real stuff come out of this, which is well defined and focused, and maybe discussed in Columbus or wherever. But it won't happen this year. So next year, these students get promoted to year 2. This you can do again with the new set of students who are in their year 1. So you have a model what to do in the first year for incoming freshmen.
Well, why couldn't we do, I would see the research projects, we didn't.
Oh, no, that could continue on.
Yeah, we could make them bigger, the groups are small and, you know, we get more people
This can
involved.
continue on. All I'm saying is year 2, which is next year for these students, what are they going to do? Is it simply going to be